Okay, today we're going to take those family of graphs that we looked at the last time and do something that we call transformations. Let's start with the easiest one. Y is equal to x squared. All right, by now we all know what that graph looks like. This is an old friend, the parabola, just a U-shaped curve. Now, let's do y is equal to x squared plus 4. When x is 0, y is 4. But it's still our old friend, the parabola. Now let's do y is equal to x squared minus 4. 0 minus 4. And I will still have my parabola. Now, excuse my sloppiness, but all three of those graphs have the same shape. So what we did, you take your original parabola that started at the origin, and when you put the plus 4, you just moved everything up 4. When you put the minus 4, you just move everything down 4. All right. So what happens if I ask to draw the graph of x minus 4 is equal to 0? Well, again, we know that it's going to be a parabola. Now let's pick the good point first. When x is 4, 4 minus 4 gives me 0, y is 0. So when x is 4, y is 0. Now, it's the parabola. So if you wanted to get more points on it, a real good point to get in this one, let x be 0. Minus 4 squared is 16. So this is 0, 16. And it's going to be the parabola. Now, an interesting thing that you need to look at real carefully is that I told you that parabolas do have symmetry. That just does not have y symmetry, but it does have symmetry. It has symmetry with respect to the line that goes through the origin. So this point 8, 16 is also going to be on the graph. And let's understand why we say that. 0, 16 was the y-intercept. From 0 to 4 is 4. So if I move 4 more units over, I'm at 8 and 16. Right? Now, so what happens if I use x plus 4 squared? Well, in this case, minus 4 makes it 0. So this is minus 4 and 0. Still, when x is 0, y is 16. So that's going to be this point right here. And then you come back over here. So this point over here then is going to be minus 8 and 16. It has a symmetry. So when you have numbers inside the parentheses, this thing is going to shift right or left. Whatever makes the x value in here 0 is your right shift. So in the first one right here, it had a right shift of plus 4. In the second one, it has a left shift of minus 4 because that's what made it 0. An easy one that we like to use is our old partner, the absolute value. All right. The absolute value is 0 is 0, 1, 1, 2, 2. All right, that's that V-shaped curve. So if I have the absolute value of x plus 3, well, when x is 0, y is 3. And it's going to be, if I have absolute value of x minus 3, then this is 0 minus 3. And just like the parabola, if I have the absolute value of x minus 4 plus 2. All right, it's going to have a right shift of plus 4. 4 minus 4 gives me 0 inside here. And when x is 4, y is going to be 2. So that's the so-called vertex of that parabola. An easy point to find would be the y-intercept when x is 0. The absolute value of minus 4 is 4, and 4 plus 2 is 6. 0, 6. Now, it has the same characteristics that the other one has. This point over here, which would be 8, is also come out to be 6. 8 minus 4 is 4, and 4 plus 2 is equal to 6. Okay, let's try to make us up an equation. So let's do our old friend, the cubic function. And let's shift 3 units right and 4 units up. So my equation is going to become now, I wanted to shift 3 units to the right. So this is going to be x minus 3 cubed. And I want to shift 4 units up. So it's going to be plus 4. Okay. Now, it's going to shift 3 units to the right, and it's going to move up 4. Now you can get some other points on it. Oh, let's let x be 4. If I let x be 4, I got 4 minus 3, which is 1, and 1 cubed is 1. So that gives me 5. I come back over here. If I let x be 2, then I get 2 minus 3, which is minus 1. Minus 1 cubed is minus 1. Minus 1 plus 4 gives me 3. So that's the same pattern that we had when we had our cubic function. That would have been here at the origin. Okay, we've already talked about this, but in a little bit different fashion. He talks about reflect, about the y-axis. Well, reflect about the y-axis says that it has to be an even function. So if I tell you that f of x is equal to x squared, and I know it sounds redundant, but let's get it. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. Now, but notice, when x is minus 1, it's still 1. Minus 2, it's still 4. Because it's an even function. So I replace the x with a minus x, and the y stays the same. So that means that it is reflected about the y-axis. All right. So let's reflect one about the x-axis. Easiest way to do that. If I draw a graph of y is equal to x squared, we're going to get that parabola. If I draw y is equal to minus x squared, then notice all your y values become negative. So we reflected this thing about the x-axis because we went from a positive x squared to a negative x. And notice that we haven't done any of them where we had a number in front of the x squared. And let's just see what that would do to a graph. If I had y is equal to 2x squared, well, the easiest way is to simply plot your points. So still, when x is equal to 0, y is equal to 0. When in this case, when x is equal to 1, y is equal to 2. Now, when x is equal to 2, y jumps up to 8. Now, and it's still an even function. So that means that I have this point minus 1, 2. And I also have this point over here, minus 2 and 8. So the number in front of the x squared simply changed how wide this parabola was. So what happens then if I draw y is equal to 1/3 x squared? X is 0, y is 0. Now, when x is equal to 1, y is only 1/3. So when the number in front of the x squared is less than 1, then that means that it's going to be wider. Okay, let's go to section 4.1. Section 4.1 is certainly going to be redundant because he starts off with 4.1 with this right here. Y is equal to 2x plus 5. Well, that's an equation that's in the slope intercept form. Y is equal to mx plus b. So we know from this problem right here that the slope is equal to 2, and we know that the y-intercept is at 5. Now, he wants you to do a couple of things with this. Number one, we're going to draw the graph, and we're going to draw the graph using those two facts. When x is 0, y is 5. That's my y-intercept. Now, the slope is 2, and 2 is understood to be 2 over 1. So I'm going to make a run of 1, and I'm going to make a rise of 2. So this point is going to be 1, 7. And then I can draw my graph. Notice that this thing is slanting up to the right, which means that it has a positive slope, but my positive slope was given 2. So he asked 3 questions. Is this thing increasing, decreasing, or constant? Well, it's certainly increasing because it has that positive slope. Now, this is something that we hadn't done a whole lot of. We can have a constant function. Now, be careful of this. So this says that regardless of what you use for x, y is always going to be 5. So that says then that when x is 0, y is 5. And x is 1, y is 5. And I don't need to put any more points down. So this is the graph of y is equal to 5. This is a constant function. Now it fits the bill because what this really says is that f of x is 0 times x plus 5. Look what this says right here. Your slope is 0. Well, every constant function has a 0 slope because it has no rise. This next problem is going to seem a little bit rinky-dink, but you got one like it in your homework, so I'm going to go ahead and do one for you. Let me just give you some points. Give you minus 27 and 0. Okay, he didn't give you the equation for this thing. He simply gives you those 3 points, and then he's going to ask for some questions. So the first thing he's going to ask for, f of x was equal to 24. You simply look at your graph. We did this with that rising and falling curve the other day. So this says that y is 27. I mean, y is 24. So my x value is going to be 27. If he says x f of minus 27, you read it straight off the thing. When x is minus 27, y is equal to 0. Okay, so how would we answer this one then? Well, okay, so this says that we're going to use the x values between 0 and 72. Now I'm in a little bit of trouble with that. So let me change my problem again. Now, I want to use the x value between minus 27 and 72. So what y values am I going to use? Well, my y values go from 0 to 44. So 0 is less than f of x is less than 44. We said that we were going to look at the x values between minus 27 and 72. And we wanted the y values that would give me that. And they go from 0 to 44. Pay attention to this next one because it seemed like a trick question, but it's really not a trick question. It's something that we need to be able to do. So I draw you 2 lines, and I call this one f of x, and I call this one g of x. And I show you that they cross over here at 4 and 7. Okay, that's all you're given. You're not given any equations. Okay, so he asked you to solve f of x is equal to g of x. In other words, where are the 2 y values the same? Well, they both have a y value of 7 when the x value is equal to 4. So you have just solved that. Now, suppose he said, all right, solve f of x is greater than g of x. Well, these x values right here, I mean, these y values here are greater than these y values here. Therefore, the solution to this would be x is greater than 4. To me, it makes a little bit more sense if I would give you a couple of equations, and I think we can do the algebra to get there. So I tell you that f of x is equal to 6x minus 5. And I tell you that g of x is minus 2x plus 3. Now, we want to solve f of x is equal to g of x. So 6x minus 5 is minus 2x plus 3. I got 6x plus 2x is 5 plus 3. 8x is 8. So x is 1. So that says then we found that when x is equal to 1, that's where they cross. So if I let x be 1 right here, I have 6 times 1 minus 5, which is 1. If I let x be 1 right here, I have minus 2 times 1, which is still 1. So that's the point at which they cross. Now, what that means then is that you can do that same thing. We know that they're going to cross at the point 1, 1. So in the first equation up here, when x is 0, y is minus 5. So that means that this line comes over here. And this is the f of x. Now, in the second equation, when x is 0, y is plus 3. And then you could answer the same question. This is f of x, and this is g of x. And there's another problem in there where you deal with a car rental. I'll just let y'all look at the course compass and do the arithmetic to work that type problem.